Given diagram shows the throttling process of pure substance, the ordinate and abscissa respectively. Here in the given process, here 1, 2, 2, and it is not a it is not constant to the x-axis or y-axis, but it varies on both the coordinates. So that it's and we know that the throttling process is nothing but a constant enthalpy process. So that enthalpy cannot be the abscissa for this diagram. So and entropy might be, and in the given options, the entropy will be the abscissa. And coming to the ordinate, here pressure cannot be the ordinate, and here temperature and entropy and enthalpy also cannot be the ordinate, and temperature might be the ordinate of this diagram. And here the right answer is temperature and entropy, and in the given option the answer is C. C is the right answer. Circular bar is welded to a steel plate. The bar diameter is 50 mm. Determine the size of the weld required if the permissible shear stress in the weld is limited to 94 Newton per mm square. And here this bar is carrying a 10 kN load at the free end, and it is welded at the fixed end, and it is of length 200 mm. Now we'll have to find out the size of the weld. So here first find out the bending moment. The maximum bending moment induced in the beam, that is M is equal to 10 into 0.2 is equal to 2 kilonewton meter, and shear force is 10 kilonewton only. Now the section modulus of the beam is equal to 1 by 4 pi td square, which is equal to 1.964 t into 10 power minus 3 meter square. So here the maximum bending stress induced in the beam is equal to sigma max or sigma b m by zw, which is equal to 2000 by 0.001964 t. So it is 1019 by t Newton per mm square. So here the the maximum shear stress induced in the bar is equal to 1 by t root of 1019 by 2 whole square, plus here the shear stress is shear force by shear area, that is 10,000 by 0.05 t into pi whole square, so which is equal to 514 by t Newton per mm square. And the size of the weld, let us say HRS is equal to, it is 514 by 0.707 into 94, which is equal to 7.7 mm. Area of air at a pressure of 7 bar occupies a volume of 0.28 meter cube, and this air is then expanded to a volume of 1.4 meter cube. Find the work done when the process is isentropic. Here in an isentropic process, the work done is given by mr into T2 minus T1 by gamma minus 1. Okay, sorry, here it is mr T1 minus T2. So here initially the mass of air is 2 kg, and the initial pressure is 7 bar, and V1 is 0.28 meter cube, and then expanded to 1.4 meter cube, that is V2 is 1.4. So here we'll have to find out T1 and T2, that is, so here from the perfect gas equation, P1 V1 equal to mr T1, where R is the characteristic gas constant and is equal to 287 joule per kg Kelvin. So here all the values are known values except T1. Now we can find out from this equation T1, so which is equal to nearly 341.5 Kelvin, and it is an isoentropy process. From that we can have T2 by T1 equal to V1 by V2 whole power of gamma minus 1, and from this equation we can find out this V1 by V2, and here T2 is equal 179.4 Kelvin. Now substitute all these values in the work done, which gives a value of 232 kilojoules. In a surface condenser, the pressure of steam is 0.12 bar. The rate of cooling water flow is 40 kg per kg of steam condensed. The condensate leaves at 44 degrees centigrade, and the rising temperature of circulating water is 14 degrees centigrade. Determine the dryness fraction of steam entering the condenser. From the steam tables at 0.12 bar, HYF is equal 207 kJ per kg, HFG is equal 2383 kJ per kg. Here, the heat rejected by the cooling water is heat rejected by the steam is taken by the water, circulating water. That is, the change in enthalpy of the steam is equal to the heat gained by the cooling water, that is MCP delta T. Here delta T is 14 degrees centigrade and mass flow rate of the water is 40 kg and Cp is 4.187 and delta T is 14, which is equal to 2345 kilojoules. In this process, generally steam leaves with a condition of saturated liquid, so that here H1 minus HF is equal to 2345 kilojoules, and here HF is given by 2345 plus 207, so which is equal to, so here it is equal to 2552 kilojoules, and this is the condition of the steam at the entrance. Now we will have to find out the dryness fraction of the steam entering the condenser. So that is nothing but HF plus XHFG is equal to 2552. So here HF is given by 207 plus and HFG is given by 2383 is equal to 2552, and from this equation we can have the dryness fraction of the steam is 0.98. Following is the use of regenerator in gas turbine cycle. So here the options are increase efficiency but has no effect on output, increase output but has no effect on efficiency, increase both efficiency and output, increase efficiency but decreases output. Here by using regenerator we can increase the efficiency of the turbine but it doesn't have any effect on the work output. So that the right option is A. A is the right answer.